So hello guys, welcome to our website named StructureX. So this website is made as a solution of the problem statement 2 of the advanced questions you provided in the Hack Olympus Hackathon. So in the second problem statement, as it is listed, to made a system for early detection of infrastructure failure. So this can be used in industrial smart cities and predictive maintenance and critical infrastructure like bridges and pipelines and whatnot. So let me give you a brief of our website. I might not be able to show you every feature of the website due to time limitations, but you can explore all of those features using the GitHub repo link we provide by hosting it on your computer itself. So as you can see, there is a beautiful map of the world in the center of our website. You can access any infrastructure, any building, any bridges if it exists through by typing it over here. So let's start by typing the IT city of our India, Bengaluru. As I type Bengaluru, so I get the option here in search bar. It zooms out in the city Bengaluru. So as you can see, all of the buildings listed here. So I can go to any area, and do note that all these buildings do exist in the real life. All these buildings are extracted from maps itself using satellites. All these buildings are real 3D models of those buildings that do exist over there. So let's click on any building. I click on this building, it would show the building name and where it is located, like everything. It shows the asset type, estimated, even the floors in that building. It shows the height, coordinates, everything that you need to know about the building. It shows the path, vulnerability, climate impact, environmental hazards, like everything you need to know about a building at a glimpse. Now this is only a glimpse which is AI powered, but now if we want to go deep, there is a resilience tab over here. It should show you life controls. You can see those controls in emergency role, public role, engineer role, executive role, like any role. Let's pick the engineer role for now. As you can see, you can pick any role over here. So basically, as we scroll through, so as I was talking, you would see here multiple options. So you will even see the role based dashboards, which is engineer. You can look at what if scenario comparisons, like everything in one website. So basically you can scroll through and see all the options basically over here: earthquake, ground motion, flood, like it lists the probability of everything on a scale of 100 in all conditions that can happen in the environment around it. Then we can go to the satellite tab, and here you can see the network health graph, traffic flow graph, like everything. What is the traffic around that area, like all the basic information that you need. It will show the active nodes and all that. If we click on weather tab, it would show the weather around it, wind gust, wind direction, like every minute detail, every single detail is mentioned over here. If I go to building AI, it is basically the thing that I showed you before. It would give the every detail, basically the glimpse of the building at one place. And if I go to selection, basically all that. So let's search anything else. Let's search a random bridge, as the problem statement explicitly mentions bridge. Let me type a bridge. I type bridge randomly on the search bar, and it randomly picked up a bridge anywhere on the world. As I click on the bridge and I click on any tab, it shows the resilience tab. It shows that its name is Kolkata Bridge, everything, and it's the same metrics for this bridge now. Hospital, backup power, like you can see every minute detail is mentioned over here. Let me click on executive now, or public, I think. And as I run the module as public, so it shows me everything, what if scenario, and now it will show the dashboards according you mentioned as public. You can even see the loss it has made of $11.3 million. So all these things, it would be mentioned, all the data would be listed over here of that in specific infrastructure that you would choose, the weather around it, everything would be mentioned over here. So now let's search one more time for, let's say, New York. If I search New York, as you can see, New York has many large buildings, so it is better to use this website and show you for New York buildings and New York infrastructure. Let's pick a pretty tall building. Let's pick this one. So as you can see, it shows the building name, it highlights that building, Broadway, it gives the history of that building, all the information you need, the weather, and all of this runs real time using machine learning and AI tools. So this is using satellites to give the network health, traffic flow, the traffic around it. The traffic usually is pretty high in New York, and everything about the weather, the building AI, the selection. You can play around with these tools, play around with these tabs on your own computer, as I told you. So let's do Taj Mahal also. Taj Mahal, as I click on it, so here is our Taj Mahal, the beauty of India, the wonder. If you click on it, it would show even for Taj Mahal. So you can check, you can know about the power of this website by the power of the website through this scenario, as it can tell for every single infrastructure. You have to just find it on the map or type it over here, and it would show everything about it. So now this is something I have told you about the infrastructure part and searching about it. There is one more special feature in our website, which is called the CSV dataset. So basically, as we have right now, I have uploaded the CSV file, and I have uploaded the information about a specific region. Now it would easily identify about the building and all the environment according to the data now you have uploaded. Now you have locally trained it. Now it doesn't depends on the internet or the machine learning about that. It depends on the local data that you have uploaded. So it will now, if I choose any building over here, it will not tell according to the data set you have uploaded. So as there is also a scenario engine over here, we can change it if we increase the temperature of this specific area, and if we increase the soil moisture, and we run analysis. Now it would change the analysis of that area, it would change the information. So basically, as doing it physically might not be feasible or possible, both physically or economically, we can do it using the pre-recorded information we have. Now we can play with all this information using these tools that we have provided in the website. Now using machine learning and AI, as increase or decrease any of the specific info that is written here, it would the uh, directly influence the building conditions over here. So whatever will happen in real life, I will not say it is 100% correct, but at least 90 to 95% correct. It would show what would happen to that building, what would happen to the infrastructure over there. So this is a great tool. So without costing a penny, we can directly run it through over here and tell in the upcoming years when the temperature is going to increase due to global warming, so what will happen to that infrastructure. So we can use this temperature, this degrees Celsius bar over here, and run the analysis as I did before, and it would interpret the data accordingly. You can see it would interpret the weather, satellites, all that. So there is also as you can see, there is a two modes. There is AI normal and AI expert. If I click on expert, you will get extra information if some expert is reading it. If you do not want this extra information, you can click on normal, and some of the information would be reduced and only a glimpse would be given to you. So we can play around with that. Also, we have all these options over here which tells us a vibration, strain, temperature, risk trend, correlation. Every single thing is present over here. Let me give you a glimpse of it too. As you can see, it would tell me the different data. It could tell me the steepness, the risk trend, the temperature. Everything is available on our website. There are pretty many tools that are available that would help you to tell about the infrastructure. It would tell about the explainability, history. You can do the analysis, insights. Now, this is pretty much it for this website. So let me take you to the about page of this website now. Taking you to the about page of the website. So this about page, it has a 3D model over here. It moves as the cursor. It moves as you move around the cursor. So there is also light mode and dark mode that you can play around. So this is our about page, which tells about our journey, how we started from the problem statements and ended to this problem statement, ended up selecting this problem statement. It tells why we only choose this problem statement instead of others, and we have some fancy lines over here. Infrastructure doesn't falls instantly, it falls silently, saying that the infrastructure, as before the visual changes appear, the internal damage is already done. So these are some things that we have explained. So why we chose this project and why this problem. So also how we built it under pressure, how we built it under such little time that was given to us. So we introduced it to you, all the features over here, as you can see. So I have also added a hover effect on it, a little hover effect. So also designed for real world use, everything that we try to cover. So this is our team. I am Arush Sharma talking to you. This is my MD Wasiullah. This is Nirmalya Ghosh. So going down, so we'll build this in a hackathon, not because it was easy, because it was necessary. The world literally needs this type of website. And yeah, this is it. You can also visit our about page from the website. So this was pretty much it. So this is it from our side. So we did the best we could in this short period of time. So thank you for giving us your time and giving us the opportunity to represent ourselves in this beautiful competition where we learned so much. And this is our website. I hope you like it, and we did the best we could. Thank you. This is it from the team Decoders.